Question number 14, 2 students must be chosen among 3 boys and 3 girls. How many possible choices are there? Okay, so if you just have 6 kids and you're picking 2, so that is going to be, and they're not, in this case, we're not saying what they're picking them for, so presumably the order does not matter. Okay, so the order doesn't matter, that's a combination, and we're not going to replace, so it's a combination without replacement, which is n factorial divided by n minus r factorial times r factorial. How many possible choices are there? We're just going to be picking amongst 6 children. We have 6 choices for the first child, 5 choices for the second, and then the order doesn't matter, so we're going to divide by 2. So 6 times 5 divided by 2. You can think of it in terms of this. 6 factorial divided by 6 take away 2 divided by 4 factorial, which is going to give you the 6 times 5. And then we're dividing by the restriction factorial, the 2 factorial, because we're going to get person AB, but AB could be chosen as AB or BA. We want the AB and BA to be reduced to just AB, so we're going to divide by 2. So that's dividing by your R factorial. 2 factorial is 2. 6 times 5 is 30 divided by 2 is 15. So there are 15 possible choices if we're just picking 2 students and we don't care about whether they're boys or girls. How many possible choices are there if we must choose 1 girl? I pretended that the first, we're just going to choose the girl, and then we're going to choose the boys. If we're picking 2 students, the first one is definitely going to be a girl, and then the second one will definitely be a boy, because order doesn't matter. If order did matter, then we would have to switch it around and choose the boy first and then choose the girl. If we pick just 1 girl, if we pick the girl first, remember there are 3 girls, we just have 3. And then we pick the boys, so that's 3 again. So 3 times 3 is 9. So we have 9. The reason we don't have to divide this by 2 is because that's if the girl is picked first. If the boy is picked first, we have another 9. And then we would have to divide that 18 by 2 factorial, and we would still get 9. We have 9. If there are no girls, if it's only boys, you have 3 choices for the first times 2 choices for the second, and then we're going to divide by 2 because the order doesn't matter. If you picked AB and you picked BA, there should be no difference between the 2. It's just AB, so we divide by 2, which gives us 3. 3 if we just have 2 girls, same thing. If you have 2 girls, it's the same as having no boys. It's still going to be 3 times 2 divided by 2, which is going to be 3. At least 1 girl. What if it was all boys? If there were no girls? Now we know there's 3 ways of picking no girls, and we know there's 15 ways of picking the students. So our total omega, there's 15 different ways. If there were no girls, there would be 3 ways of doing that. So we just have to remove the 3 ways of doing that from our 15. So 15 take away 3 would be 12. So there are 12 ways of picking no girls. And that is it for question number 14. Have a good day.